Good morning, dear students. Welcome to this session on moment distribution method. So, last session we have talked about the stiffness expression for stiffness that is coming around 4EI by EL. Okay, so the expression which is derived for stiffness of the member when moment is applied with one end fix and one end hinge. Okay. Right. In this session, let us derive the expression for distribution factor. Okay. It is already defined what is meant by distribution factor. That this is the definition that we have given for distribution factor. So when you have four members meeting at a joint, this is the example taken. So four members meeting at a joint OA, OB, OC, and OD. So there are four members meeting at the joint O. So what distribution factor means when a moment capital M is applied at the joint. So imagine member OA is taking some moment or resisting some moment which is called as M suffix I. Okay. So I may be one, two, three, four. The so many members that joint will have. Okay, if there are three members, we'll have M1, M2, M3. If there are only two members, it will be M1 and M2. Mi means I becomes 1 to n. So many number of members meeting the joint. Okay, so it is the ratio of moment shared by a particular member divided by moment applied at the joint. Okay, so that is the no, expression, the definition that is being given in the earlier sessions. So let us see what is the formula to find distribution factor. Right. So capital M is the moment applied at the joint. Okay. So imagine M1 is the moment shared for member OA. Okay. Whereas M2 moment shared for M2 OB. Okay. Similarly, M3 moment shared for member OC. M4 moment shared for member OD. Okay. So if you add all those values, we shall get applied moment M at the joint, right? Because M is shared to each member. Okay. So how much it is shared, we don't know. Okay. Just we are imagining that some M1 is shared to member OA. Likewise, M2, M3, M4. Okay. Right. So what is theta? So when you apply the moment at the joint, means joint is rotated. So every member will rotate at that joint. Okay. So imagine that the angle rotated by the joint is theta. Okay. See, before moment is applied, these are the members, vertical and horizontal. After moment is applied, see this member is deforming like this. Got it? And this member is deforming like this. This member is deforming like this. This member is deforming like this. Okay. This is how the joint is rotated clockwise and the members rotated like that, whereas all the far ends are fixed. That's why the deformed shape shall be like this. Zero angle should maintain at the end. Theta should be zero at fixed end, right? So that's why this is the nature of it. So if you draw tangents to these deformed shapes, this is the tangent, this is another tangent. So they should have 90 degree. See, this is the line before moment is applied, and this is the line after moment is applied. So the angle between them is theta, that is the angle of rotation. Right? So the horizontal line rotated like this, okay, by an angle of theta. So that is theta here. Okay. So theta for every member, the angle of rotation is same theta. So this is the line which is making an angle of theta with this. Okay. So similarly, every see opposite angle is same. So theta. Similarly, this is theta, and the opposite angle is also theta. Okay. Right. So now if you see, this is M1, that member OA is the share of member OA from capital M. So M1 by K1, okay, is theta. Right? For each and every member, the rotation is theta. So in fact, K, I shall write like this: K1 is equal to, means stiffness of member OA is equal to moment applied for member OA is M1 divided by theta is theta only. So now I want theta, so M1 by K1 it will be. Similarly, all other members, M2 by K2, M3 by K3, M4 by K4, as angle is same for all the members. So I take this as theta. Okay, got it? So the joint rotation is nothing but rotation for members also. Okay, so now theta is equal to, what is M1 plus M2 plus M3 is M, right? So now this is for individual members. If you write the theta in the same way for the joint, so what I call it as, say K is equal to joint stiffness, let's say, is equal to moment applied at the joint divided by angle of rotation of the joint. That is theta only. Okay. So now what is theta? M by K. So what is M, moment applied at the joint, is equal to moment taken by M1, moment taken by member 2, moment taken by member 3, moment taken by member 4. So this is the M1 is nothing but share of OA, moment share of OA. What is M2? Moment share of OB. M3 moment share of OC. And moment shared by OD is M4. Similarly, what is K then? Joint stiffness is nothing but stiffnesses of all other members, K1, K2, K3, K4. K means total joint stiffness. Okay. So now theta is equal to M divided by K. I write it as sigma Ki. This I am replacing the denominator with a simple expression, sigma Ki I is equal to 1 to 4 because there are 4 members here, or else I should have written n. N can be any number depending on the given problem. Okay, so this is angle of rotation theta applied moment m divided by sigma ki. Right. So what is mi is equal to ki into theta. Okay. So it is theta for a particular member. I mean stiffness of member OA. If I want to write it, say I shall call it as some member I, can be 1, 2, 3, 4, right? Moment by theta. Theta is common for all. Okay. And m will be different, m1, m2, m3, m4. So this is the expression. So how do you write theta now? Mi by ki. Okay. Or how do you write mi is equal to theta into ki? So mi is equal to ki into theta. So ki into, what is theta from this joint rotation expression? Substitute for theta here. It is m by sigma ki. Okay. So ki into m by sigma ki. So distribution factor formula mi by m. So substitute for mi, that is ki into m divided by sigma ki. So divided by m, so m gets cancelled, and now ki divided by sigma ki. So this is distribution factor. So how you calculate distribution factor for a member? It is stiffness of that member divided by total stiffness at the joint. What is sigma ki means? K1, K2, K3, K4 is equal to K, total K. That means stiffness of the joint. So member stiffness, this is member stiffness. Okay. What is this one? Joint stiffness. This is joint. Okay. So what is distribution factor? How you calculate the distribution factor? You know stiffness values for different cases. See 4EI by L just now derived. Okay. So what is stiffness value of a member? 4EI by L. So you know E value if you know, and IL you can calculate K for each member. So if you want to calculate distribution factor of member OA, it is K for OA. This is distribution factor for OA. K of OA by sigma K. It is joint stiffness. Likewise for member OB, member OC, member OD. Okay, this is distribution factor. Again, total distribution factor should be 1, as earlier I have not told you that the distribution factor sum is equal to 1. Okay, so this is how we calculate distribution factor. Okay, so we started with the moment applied at a joint, then we have related that to the angle of rotation of each member and moment shared by each member, stiffness of each member, and we related that to the joint stiffness, okay, and moment applied by the joint. So we wrote theta expression. Then we have taken member, moment shared by member, and moment stiffness of the member. Then substituted theta there. We got the expression for moment shared by a particular member. Then the same is substituted into distribution factor formula, and that is giving you the distribution factor formula. So finally it is Ki divided by sigma Ki, means stiffness of a member, a distribution factor of a member is equal to, for a particular member at a joint is equal to stiffness of a particular member divided by total joint stiffness. Okay, right? So this is the different terms required for moment distribution method and their definitions, mathematical expressions, as well as formula for calculating the quantities. So carryover factor is 1 by 2, carryover moment is m by 2, and stiffness is 4ei by L, and distribution factor is k by sigma k. Okay, so this with this what is required for moment distribution method is we have discussed. So next session we will talk about procedure, how to calculate the end moments, or how you solve a particular problem with moment distribution method. Okay, thank you.